Well then, let's begin. I'm very excited.
Hello, everyone. Welcome to the Discovery Center tonight. We are so excited to have you here for this wonderful evening ahead of us. My name is Amanda. I'm one of our education coordinators here at the Discovery Center, kind of the mind behind Superstellar Friday. So if anyone has any topic ideas they're really excited about, you're welcome to let me know, and I'm happy to try my best to get them. But we have a great presentation here for you this evening from the Flying Gravity Circus Circademic Squad. I want to just name everybody that's here with them tonight so we can give them a proper introduction. So over here, we have Jackie. Next to Jackie, we have Ella. Next to Ella, we have Gabe. And then some of the behind the scenes stuff. Over here, we have Nora. She's handling some of the volume that we're going to have. Then behind you all, we have Peter. So we are so excited to have them here this evening to talk about the science of juggling. And after they have their wonderful presentation, you're going to get a hand at juggling yourselves. Okay, for anyone that wants to, no pressure if you do not. It's very fun though. There's going to be some little breakout workshops that you can all enjoy. I think you're going to have a great time. But without further ado, I'd like to welcome the Flying Gravity Circus. Yeah.
Okay, that's a hazard. Don't step there, that's, don't there, that's dangerous. That's, look at this. My goodness. What a mess, you guys. Try drop it a little bit less. Okay. Oh. Back here. Danger. That's why there's tape here to protect you. They're just plastic, really. Very much. Maybe they might hurt a little bit if you did it in them. Anyway, don't worry. You're protected by the space of tape. That's protecting and saving their lives.
It is time to begin. We are super serious about being on time. Allow us to introduce ourselves. I am Dr. Newton.
And I am Professor Spin of the Flying Gravity Circus Circademic Squad. And we are here to present the Science of Juggling.
Begin with gravity. Gravity is very important for juggling. Without it, you could throw a juggling ball and it would just keep going up and up and up through the roof, through the sky, and right out of the solar system and never come back. This would obviously be a problem, and gravity helps prevent this. But what is gravity? Well, gravity is a force. A force is simply a push or a pull. Can you hold this plate? Oh, yes. So what's your name?
Mimi.
Thank you, Mimi.
You're welcome.
Now, there are many different kinds of forces, But gravity is a special kind of force. It acts on things that have mass. Now, mass is simply a measure of how much stuff something has. Everything around you has mass, but some things have more mass than other things. For example, this large object here has a great deal of mass. Could you hold this, please, Mimi? Thank you.
Where's the squishy orange one?
The squishy orange one is right here, Mimi.
Oh, you found
The
it.
squishy orange one has much less mass.
But it's the same size. I don't understand why this.
Well, that has to do with the property of density, but I digress. Anyhow, do you know what has a lot of mass? The Earth. Since the Earth has so much mass, things are very, very strongly attracted to the Earth, so if you just let them go, they will fall to the Earth. However, small things have much less mass, and gravity is weaker for small things, so if you drop two juggling balls, for example, they won't be noticeably attracted to each other. This property is very convenient because it means that when you're juggling, you don't have to worry about the gravity between two juggling balls, only between the juggling balls and the Earth. As you can see, the juggling balls just fell straight down without moving any farther apart but closer together. Now, it is an interesting property of gravity that although it is stronger for heavier objects are also harder to move, and these effects just happen to nicely cancel each other out. So, if you have a light object and a heavy object, and you drop them, they'll fall at exactly the same speed.
No, that's not true.
Yes, it is.
How could that be true?
Would you care to test it, maybe?
Yes. How do I do that?
You pick up a heavy object and a light object, and you drop them at exactly the same time and see when they hit the ground.
There's no way they're gonna land at the same time. Are you with me? Yeah, place your bets. Same time. Say I need a little countdown. Can you say 3, 2, 1?
3, 2, 1.
Did they land at the same time?
Yes.
How did you do that?
It's not me. It's the science of juggling. Also, gravity. Not just a good idea,
It's the law.
Now, because of this exceedingly useful property of gravity, you can predict how almost any object will move without knowing how much mass it has. So you could juggle things of all sorts of different masses, and they will all have nearly the same trajectory. A trajectory is simply the path in which something moves. Now, for juggling balls, that path is a shape called a parabola, which looks like this. You can see a parabola, it goes up and it goes down. But importantly, when you juggle, the parabola isn't quite the whole story. You see, objects move in parabolas when they're falling under the influence of gravity alone. But gravity is not the only force that acts when you juggle. When the juggling ball is in your hand exerts a force on it also to move it sideways and up in a shape called a lemniscate. A lemniscate is sort of like a sideways figure 8 or an infinity sign, and it includes parabolas as part of it. There's a parabola here where the juggling ball is in the air, and one here where it's in the air going the other way. And these parts are in your hand. It is very important that the two parabolas are not on top of each other, because if you try and throw two objects in opposite directions along the same trajectory, what do you think will happen? Exactly.
One, two, three. Did you crash them?
Yeah.
It's true.
And this is the importance of lemniscates. But back to trajectories.
Oh, yeah.
You can change the trajectory of an object simply by changing how it's thrown initially, so its initial speed and direction. You can make really wide throws, really high throws, and so you can make juggling patterns that look all sorts of different ways. You can see these are all still parabolas and still lemniscates. But the initial speed and direction changes the pattern altogether. And if you're willing to get rid of the lemniscates, you can do all sorts of other fantastic things, like this. Or perhaps like this. That's an excellent example of gravity.
I can do that. That's my best trick.
And this is all simply due to changing the initial speed, the initial direction, and where it's thrown, where it's dropped, and using the effects of gravity on the juggling balls.
I got it. Gravity is anchor. Good.
All right. Now, anyway, gravity is good for more than just juggling. It's also exceedingly useful for balancing things. You see, any object has a very special point called a center of gravity. The center of gravity is the point where gravity acts on the object. For this broom, it is probably about here, near the heavier end of it. And in order to balance something properly, you need to support it directly underneath the center of mass. If you don't, so the support's not under the center of mass, it will simply fall over. Mimi, would you care to demonstrate? Stop! It is time for our snack. We are very serious about snack time.
Hey, snack time. Yeah, I didn't bring a snack, did you? I didn't bring a snack. What did she say? Put the thing under the thing? The thing under the.
There's no snack.
No, I don't have a snack. I just have a fruit. Fail. Gravity 1. Mimi 0. Oh. Oh. Boy, hope this doesn't fall down my throat. Go try this at home.
You try that out.
Goodness, what a mess. Sorry, wait, I'm just cleaning up. I forgot. Have to tidy up. That's my job. No gravity is taking. It's really quite serious. Oh. Sorry, sound people. Well, just wait. Well, thanks. I wanted it under the table. Where did? Of course, you know. We're gonna save that for after the show. Okay. That's it. Second. Can you juggle with your armpits? I can. But wait, she was doing some super cool. The lemon skates and the thing and the parabola. Somehow saying that word didn't make it happen. Okay. Something about mass. I need more mass. The more mass, the more likely I'll succeed.
Run away!
Stop.
Sorry, that was me. Peter told me not to do it and I did it.
Stop.
Yeah,
We
okay.
must be super serious if we're going to learn how to juggle.
It's quite simple, really. Just take a look at this pattern. You see, like this.
Okay.
Or over here works too, yeah. This is the pattern.
This
Yeah.
one's called a cascade.
And this is the reverse cascade.
It's a nice simple
Okay.
pattern.
You guys are
This
good
is Phil's math.
physicists, but you're terrible
And
teachers.
this is collage. And so you see, just try this.
I do it, but it's,
Just
oh,
like
don't hit your sister. What's it?
this. Just like this.
It's so,
Hey, it's too fast.
thank you.
How can we slow down gravity?
I know. How can you?
I know.
What?
Air resistance.
Air resistance slows down gravity?
Well, sort of. You see, air resistance is basically another force. But when something's falling under the influence of only gravity, it behaves like the parabolas we discussed earlier. But things aren't always behaving only under the influence of gravity. You may have noticed that there is air in this room. Otherwise, you might have a great deal of difficulty. But anyhow, this allows us to deal with the useful effect of air resistance. You see, the air is made up of little tiny particles called molecules. And when something is traveling through the air, or simply moving in the air at all, it'll bump into the air molecules and slow down. You can see this if you have a peacock feather that you balance, for instance. It will fall very slowly as it has a large surface area and bumps into a lot of air molecules.
Oh,
Meanwhile, if you try to balance a balloon, it will fall more quickly.
oh yeah. Am I gonna fall off the stage yet?
No, not yet.
Tell me.
You're getting a little close to the edge now.
Wow, that took a long time to fall.
Now, air resistance exerts a much larger force on larger objects because they can bump into more molecules. So something like a scarf will fall much more slowly than something like a juggling ball.
Oh, you lost.
Gravity to Newton 0.
Wow.
Anyhow, the technique for juggling scarves is slightly different than that for juggling balls because air resistance acts on the scarves as they move up also. So you need to really reach up and push against air resistance, and then you can let them fall and catch them at a nice, leisurely pace. It's like slowing down gravity.
I don't like it.
We are super serious.
Not me. There's gonna be a crescendo in the music here in a second. Getting ready. Wait for the crescendo. Science Squad.
Stop. Having a little too much fun. We must be super serious if we're going to teach the science of juggling. Huh. Perhaps it is time for our secret weapon. Math. Now, my calculations are correct. You have a 75% chance of learning how to juggle once we teach you the language of juggling.
What?
Now, jugglers like to make things complicated, but when we're talking to each other, it's somewhat hard to understand if I do something like this, and then someone else does something like, I don't know, this, and then pretty soon we get all boggled. So what we do is we have made a system, a language almost, where each throw is a number. So it makes it pretty simple once we understand it. And this is called sight swap is the language. Now, we'll start with a 1. It's the, well, a zero pattern is very hard. It is this. This is 0. Go ball. There you go. You got it, maybe? Okay.
I can juggle.
Oh, 1 is this, because there's the number minus 1 beats to throw another ball. So right now there's no other beats to throw another ball. Can't throw another ball in there. It's just 1 going back and forth. Do you think you can do that, Mimi?
Yes,
For 1?
but only on Tuesdays.
Oh,
I can try it. It's Friday, but I'll try a 1.
hey, that was a 1. So we have a 0, we have a 1, and a 2. A 2 is almost as hard as 0. This is 2. Just this. A 2, well, if you could do it a little differently, this is a 2. 2 is going back and forth. Which means that there's a 2. You subtract 1 from 2. There's 1 other beat to do something. So that's your other beat you can do something with. So right now we're doing 2, 2, 2, 2, 2, 2, 2, 2, 2, 2.
Are you taking notes? There's gonna be a quiz.
And 3 is when we get to the pattern that we usually see. We've shown it a couple times already. I use a red juggling ball. 3 is this pattern. 3, 3, 3, 3, 3, 3, 3. Just pay attention to the red ball. You can see it's going 1, 2, 3, 1, 2, 3. There's 2 other beats underneath the red ball. So funny.
I know 3 is an inherently funny number.
However, we are here to be super serious.
Yeah.
Super serious. 1, 2, 3, 1, 2, 3, right? So
Right.
with 3, this is 3. So then what's 4? 4 is, get a 4 going here. 4 is this. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. And you can see that the red is staying on one side and the white balls are staying on the other side. With the 3, the red ball crossed. So once we move up to, let's say, it's a 5, let's also look at the red ball now. See if the red ball crosses or stays on the same side.
That's 5 balls, you guys.
This is
I was gonna learn that when I turned 50.
this. So even numbers, 2s, 4s, 6s, 8s,
100s.
100s. 100s is an even number. Yes, they stay on the same side. Odd numbers, 1, 3, 5, 7,
107.
all the way up to 99. Yep. Cross. So now we have the numbers represent the throws, right? And that's how you can say, oh yes, I'm juggling 3, and the person who you're talking, oh, that's a drop.
Sudden gust of gravity.
So check those out LIGO.
So you're talking to someone great. But what you can do with this is you can combine numbers. So instead of just saying 3, 3, 3, 3, 3 all day, you can say, oh, well, what if we throw in a 4 or a 2? So this pattern is a 4, 2, 3. And it keeps repeating. So the 4s are the ones on this. Oh, nope. Yes. This is 4, 2, 3. The 4s are the ones on the sides. The 2s are the ones I'm holding here, 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 and here.
That's
And
really
the
fun.
3s are going back and forth. So this pattern, if you were talking to a juggler, is 4, 2, 3. Look at another one, 4, 4, 1. 441, 441, 441, 441. You can see the 4s on the side, and the 1 is going back and forth. And we'll look at one more with 3 balls, 5, 3, 1. So that's going to be a high throw that crosses, a medium throw that crosses, and then one that zips underneath. Looks like 5, 3, 1, 5, 3, 1. There it is.
Are there more patterns than that?
There are so many more patterns. In fact, there's a special property to site swap where if you take all the numbers in the pattern, so let's say 5, 3, 1, right? We can add up the 5, the 3, and the 1. So 5 and 3 is 8.
Yes.
Yep, 8 plus 1. We have
9.
PhDs, right?
I
Okay.
think so.
9, and we divide it by the number of numbers. So 5, 3, 1, that's 3 numbers. We divide 9 by 3, we get 3. And that's the number of balls the pattern requires to juggle. So just based on the numbers and the number of numbers, we can tell if it's a valid site swap. So Mimi, I think you have some site swaps there.
I do.
We'll see if we can translate the numbers into what it actually looks like.
Can they help?
Yeah.
I need some help. I got to put some things in my hat. Don't pay any attention to the lice. Who would like to draw something from here? Would you pick one of these cards? Don't peek. That's a good one right there. Can you say out loud, really superly loud, what the numbers are? 7, 4, 4, 1. 7, 4, 4, 1.
4, 4, 1. So what's that going to look like?
What is
Well,
that?
let's see how many balls it requires first. So 7 and 4 is 11 and 4 is 15 and a 1 is 16 and the number of numbers is 4. So divide 16 by 4. It's a 4-ball pattern.
Obviously dolls.
So let's see what it looks like. So we're going to have a 7 that goes high and then a 4 here and then a 4 from the other side and then the 1 that zips underneath. 7, 4, 4, 1. Awesome.
Should we move the numbers around?
You can, but sometimes they end up like 2 balls are going to the same hand at once.
Oh,
And
no.
that doesn't really work. So
Oh,
sometimes it works and sometimes it doesn't.
yeah, that's like math.
So 7, 4, 4, 1 is
For
7.
me.
Whoop, that's just not that. Okay. 7, 4, 4, 1. There it is. I'll do it again. 7, 4, 4, 1. Okay. There you go.
Okay, everybody. Who else would like to pick one? Way back here. If I go in front of that thing, is something happening? Okay, here you go. Pick the good one. I see that you have a Harvard sweatshirt on. That's good. You're gonna get the good one. What does it say? Oh, boy. Oh, yeah. We should have put underlines.
6, 6, 6, 6, 1.
6, 6, 6, 6, 1. How many balls would that require? 6 times 4 is 24. Plus 1 is 5. So 5 divided by 6, 25.
25 balls.
25 balls.
I have to do it again.
25 balls. Let's try that again.
You should see my checkbook.
6, 12, 18, 24, 25 divided by 5 numbers. That is a 5-ball pattern.
1,
Let's see. This is the more
another
difficult
one, another one, another one more that, I'm sorry, I was counting.
Okay, here we go. So a 6, 6, 6, 6, 1 is 6, 6, 6, 6, 1 underneath, and
There we go. Oh, we got, oh my goodness. Okay, yeah, we got 2 more. We'll get you in a second. You guys reach it at the same time and pull out the same card. Ready? Twist your arms together. Okay. We're working together in circus. Pick the good one. Here you go. What does it say? 7, 5, 3, 1, 4. That's a zip code. Where? That would go to. Sorry.
where's that?
7, where's that?
I don't
Far,
know.
far. It's
Anyway.
not on the East Coast, it's somewhere else.
Well, we
7,
can
5.
add up the numbers.
3,
So,
1,
so a 7 and a 5 is 12. 12. And 3 is 15. Yep. 16 and 4 is 20 divided by 1, 2, 3, 4, 5 numbers. So 20 divided by 5 is 4. It's a 4-ball pattern.
Obviously, duh.
Okay, so let's see what it looks like. It's going to be a 7, a 5, the 3, a 1, and then a 4 on the side, and then it's going to start over 7, 5, 3, 1, 4. Okay, so we'll see if it works. It's a 7, 5, 3, 1, 4, 7, 5, 3, 1, 4, 7, 5, 3, 1.
Oh my God. I promised, I promised. Are you getting it? When you go home, you're gonna do it, right? When you do have the workshop hereafter, you ask her, do that side swap thing. Okay, did you want to do this together? Did you see the twisty arm thing? Yeah, you could do it. Okay, pick out that one, because it's the only one. Okay. What did it say? Good, we're gonna end on a kind of a nice, easy chill. 7, 4, 1, now you.
1, now let's
See it
see how many
again.
balls that is. Do you want to try to add them up?
1, another one, another one. More of them,
Yep.
and then the last one.
Yep, exactly. So, what?
Can you add them? 7 and 4, use your fingers, use
Yeah.
your mother's fingers. She has more fingers than you do. Well, no, they're just longer. I'm sorry, I got distracted by
I
the
would listen
fingers.
to you. It's awesome.
Don't
Okay.
listen to me, that's your first.
8 and 4 is 12. So 12 divided by 3 is 4. It's a 4-ball pattern again.
Dog.
Lots of 4-ball patterns. Yeah.
Of
Okay.
course it is.
7, 4, 1.
It's gonna be a high one.
Let's try this. I think it's a 7, a 4, and then that ends up, and there's still a ball in this hand, which we can't use. So then we put 3 in one hand and 1 in the other. So then they end up in the same hand. So it's going to be a 7, a 4, a 1. And then the 7's, nope, a 7, a 4, a 1, and the 7's going to come on the other side. Let's try, right?
Yeah, I'm ready.
Okay. 7, a 4, and a 1. Oops.
Don't worry, the gravity's really strong right there.
Yeah. And 7.
Isn't that amazing? Thank you. One more.
Maybe,
Oh, yes.
you give it a try.
Oh, no. 7, 1, 0,
Maybe you should start with a 1.
1.
1.
That was, this way.
Ooh, very nice.
I got 1. Now, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Sorry.
Now try 2.
2, 2, 2, 2, 2 minutes in 1.
Very nice.
I'm juggling.
That. Try a 3.
Oh, no. That's the which is parabolas and stuff of the skates and the 3
Yes.
like this and it switches hands.
Yes, the scramblers, the lemon skates.
Those are such multi-syllabic words. I vanished it. Oh. I'm only doing 1.5. Oh, now, oh, what happened there? She's sneaky. Watch out for Professor Dr. Newton. Happening. Oh, you have to start, right? You go. Ah, whoa, 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 whoa. Oh. Ah, 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 ah. That one's broken. There we go. Gee, wins. Wow, these are, wow. Oh boy, was that juggling?
That was juggling. Congratulations. That's a lot of super hard work. But now the fun begins. Oh. Did I say fun?
I heard you.
I meant it is time to learn more super serious science.
Yeah, wipe that smile off your face.
I am referring, of course, to the properties of angular momentum.
Oh. More syllables.
Now, angular momentum sounds fancy, but it's quite a simple concept. It just describes things that are spinning and how fast they're spinning and which way they're spinning. So something that's spinning really, really fast will have more angular momentum than something that's spinning really slowly. which way it's spinning matters. So something that's spinning this way will have a different angular momentum than something that's spinning this way. And heavier things, so more massive things, have more angular momentum than less massive things.
Of course they do.
Now, interestingly enough, the angular momentum also depends on how the mass is spread out. So if something's really far away from the center, it'll have a lot of angular momentum, even if it is spinning very slowly. But if it's all the mass is close to the center, it'll have less angular momentum, even if it's spinning really quickly. So the way that you spin something, for that reason, can actually affect the way it moves, which I'd like to demonstrate, Professor Spin.
Too much fun there.
No, it's super serious.
Okay.
I just demonstrate spinning it around this axis and around that axis.
Oh, yeah.
As you can see, this behavior is quite a bit different than that behavior.
It's behaving differently.
The angular momentum is important for juggling because it helps stabilize things. Angular momentum doesn't like to change unless you do something, like exert a force on it to make it change. So if something is spinning one way, it won't want to suddenly stop spinning or change direction, so start spinning faster. So something that's spinning one way will keep spinning that way, and it won't tip over as easily. This helps us to juggle rings or round things. Plenty more of these. Perhaps we could buy some in the shop. I know they're selling them.
Yeah.
And then you too could learn about angular momentum in your very own home and about juggling.
Wow.
But anyhow, these rings are spinning, which helps them to stay up and not tip over. But thank you. Angular momentum also helps you throw things sideways.
Oh, boy. This is so fun.
Fun.
Wow.
Okay, so super serious science of juggling. Let's talk about something else now, shall we? Can I have one of those clubs, please? Professor Spin. Thank you. This is a juggling club. It spins this way, and it spins this way. And when we're juggling them, we like to have them spin this way because they're very split out from the middle, so they have a lot of angular momentum and they're stable. Also, because they look cool. I meant adjust the stability. Forget the cool thing.
Don't never forget the cool thing.
So you can juggle objects like this, and aside from the spinning making them more stable, they'll behave exactly like anything else. In physics, simple models can work well to describe even complicated motions. Professor Spin, would you care to demonstrate?
Some complicated motions.
Yes, some complicated
Okay,
motions.
here we go.
Let's clear some of the deck
Yeah,
here.
I think so.
Complicated,
How many?
buckle up. Buckle up, he's gonna do some complicated.
Complicated motions should we do?
The
Complicated motions? Complicated motion music. And yet more complicated moves.
Wait. Five. That was very inspirational. I feel completely ready to try something like that.
Isn't it impressive that you can do all that with just the simple principles of gravity and mathematics and angular momentum and air resistance? Mimi, why don't you give it a try?
Well, I feel very inspired by you. Sir Spin. It spins by itself.
Yeah.
Especially designed to do that.
Center of gravity and stuff. Oh, yeah. I get it. Oh.
Now that Mimi can juggle, we could all juggle together. Do you think that might be
Very
fun?
do think so. But what do we have to do in order to do that?
In order to juggle together, we have to juggle in the same rhythm
Oh,
at the same time. And to do that, we have to listen to each other.
uh-oh. I guess, okay, here we go. Okay. That's not together. Huh? Yeah! Four, five, hop. Boy, thank goodness for science and math, so I could learn how to do that.
So, what did we learn today? The science of juggling is super serious. After all, gravity's not just a good idea, it's the law. And learning about science can definitely help with the juggling. But Mimi reminded us that doing juggling, especially with friends, is super fun. And fun helps you learn, and learning is super serious. So you can have fun learning science. Thank you.
Let's bring them out, everybody. This is the Circademic Squad of the Flying Gravity Circus. Do you have something to say? No, okay. And we have Gabe over here, Gabe Scott, who played Professor Spin. And we have Ella Glass, who played Dr. Newton. Myself, Jackie Davis, I was Mimi. And we want to also make sure we thank our friends, Peter Martell and Nora Glass, for making it so you can hear us. I know she's going to play the music in a minute. And then, of course, we want to thank the fabulous folks here at the McAuliffe-Shepard Discovery Center for inviting us to this thing. So let's see, can check my notes. What else? Let's see. Oh, yeah, so in a minute, you're going to get a bit stretch, and we're going to have some workshops where you can try some stuff. I have no idea what time it is. What is
7:58.
7:58?
7:50.
Oh, perfect. Joe. Whoa. Okay. And so, but first, a few public service announcements. Number one, if you liked what you saw, and you want to do more circus at home, which I would think that you would after such a super stellar performance, we'd like to present the idea that you might like to purchase this book in the shop over here. It's called Do It Yourself Circus Lab for Kids. And it has how to make your own stuff. And there's video tutorials for free after you get the book that you can learn how to do this stuff at home and have your own circus at home. And when I wrote it, it's by me. So it's for sale over there. And then you can have more circus in your lives. But speaking of having also more circus, we want to make sure this is top secret just for the people in this room. On December 28th, between Christmas or Hanukkah and New Year's, in Wilton, New Hampshire, which is an hour south from here, there's a show called Starburst, Family Friendly Circus. And if you liked what you saw here, it's nothing like this. No, this is a fundraiser for the Flying Gravity Circus, and it has super awesome, super serious circusers like the people that are just right here, but also alumni and professionals who come and give a really rock star show. And because you're here right now, if you got one of these from our board president, Gretchen Ziegler, let's give it up for the board president. And the board treasurer is in the house as well. So you can give all your money to him. But this little piece of paper that Gretchen will give you has a secret code on it, McAuliffe. And if you go on here, you'll get $5 off your tickets. And that's worth the hour trip if you live in Concord. And it's in the afternoon at 4:30. So you can go see the show, get out, have dinner, come home. It's like super family friendly. We would love to see you come down there. So grab one of these from Gretchen when you're done. And now, are there any questions? One or two questions before we go to the workshops? Any questions? Like, why did you choose to do this for a living, for example? Yeah, I thought it was a funny question as well. All right, folks. Well, here's what's going to happen next. And thank you, Amanda. Did you have to say some things? Housekeeping?
Just one thing after you're done.
Yeah, like in the case of sudden drop in cabin pressure, those kinds of things. Okay, Amanda's going to say a thing in a minute. But what's going to happen is this, if you want. So that she'll talk about the thing that's going on outside. But what's going to go on inside is right down here, we're going to have Ella with, no, me. We're going to have me right down here with peacock feathers and spinny little frisbee things to try doing those little things here for fun. You could do that for a little while and go somewhere else, or you could just stay or whatever. Over there, in that room over there, Ella is gonna have scarves and you can play with some scarves. And right over there by the airplane, Gabe will have some bean bags if you want to try to juggle some balls, or if you already know, you want to kind of get some tips from Professor Spin. So we have ball juggling over here, and scarf juggling over here, and peacock feathers and spinning things right here. Sound good? Yes, and something from.
I'll be over there.
Oh, and President Gretchen will also be over there in the light by this replica of the Mount Monadnock shelter, where I'm really glad I'm not. Where I'm glad I'm not right now. Amanda.
All right, everyone. Whoop. Let's give them another round of applause. Doing this tonight. So for anyone that would like to join us for the planetarium show this evening, you are all welcome to. We're going to be getting started with that, opening the doors at 8:15. So we'll have about 20 minutes for lots of juggling and practicing on that. Okay. After that, the clouds have rolled in, unfortunately. But I don't know that we all want to stand out in the cold tonight. So there will be some future telescope opportunities at future Superstellar Fridays, but our lovely friends from the New Hampshire Astronomical Society have decided to go home tonight just because there's no opportunity to see anything. But coming up in January, if you want to start marking your calendars for all those wonderful astronomical events for next year, we are going to be having a presentation all about what's going to happen in the sky in 2026. So we hope that you'll all be there to join us. But again, I'm going to turn it back to them so you can practice your juggling, learn a lot from them as well. And again, at 8:15, we're going to open up those doors for the theater for anyone that would like to join us for Max's Tonight Sky presentation this evening. But thank you all so much again for joining us, and we hope to see you again soon.
Thank you.